Hi, everyone. Thank you so much for joining me, especially after lunch. I appreciate the team effort. I hope you're going to enjoy the talk. So thank you so much for coming today. My talk is it's called 0000 Day, how we exploit local networks through the browser. And I wanted to start with a question. What if I told you that all the websites that you visit can access your local network through the browser? And it's still possible today with all public browsers. Sounds scary, right? Well, let's talk about it. So first of all, I want to introduce myself. My name is Britt Frenkel. I'm a senior software engineer at Localhost Security. I love software development and innovation, and I always like connecting a vulnerability with the background story, understanding what made the vulnerability actually possible to be exploited, and what are the concepts that were skipped on the way there. I also really love languages, whether they're programming languages or human languages, and I'm currently working on my French, Spanish, and German, so come say coucou, hola, or hello afterwards. I'd love that. So today I'm going to bring you my team's research, and I can't talk about this without mentioning my very own teammate, Avi Lumelski. Avi is an AI security researcher, and he loves internet-facing products and AI and breaking AI. He unfortunately couldn't make it to this conference, but he wrote our blog post, and he led the research that we were working on together. So we both work for Localhost Security, a cybersecurity startup that focuses on runtime detection and application in cloud infra. And working for Localhost, we conduct these security researches to write blog posts and to discover how we can improve our product. And we both come from a background in cybersecurity. Thank you, Avi. So what are we going to be talking about today? Today we're going to be talking about how a bug and a disputed CVE resulted in remote code execution. But how are we going to do that? First of all, we're going to go back in time and talk about the bug report that was the root cause of this problem. Then we're going to move on to talking about PNA, the solution that tried to solve this problem. We're going to move on to 0000 Day, the vulnerability that PNA overlooked. And I'm going to give you an example called Shadow Ray, a real-world example. And we're going to finish with current browser's state and a conclusion. So let's dive in. So once upon a time, there was a 19-year-old bug. I'm taking you back to 2006. I'm talking no HTTPS, the beginning of commercial internet. It's the time we all had Windows Vista back home. This bug report appeared in 2006 on Bugzilla, Mozilla's bug tracking system. It suggested to block access to local networks from public websites running in the browser. But this bug report raised some questions. Is it a bug? Is it a feature? Is it a vulnerability? Let's find out. So the bug report listed that the JavaScript code that runs in the browser can do numerous things. One of them is scan internal networks. The other is fingerprint devices in your local networks, and also run malicious commands. They suggested that Firefox prevent accessing internal URLs and networks from the browser. And I just want to remind us all that this blog post, 2006, was way before Chrome was even released. So just so you understand how long this bug report has existed. Later, the author also stated that the bug is currently exploited out in the wild with an attack called drive-by farming. It's a super interesting attack. We don't really have time to get into that, but I recommend everyone to read a bit about it later. It's one of the first recorded attacks known through browsers. But someone later commented that this is not a Firefox-specific problem, and it's technically not a bug, but a requestment for a security enhancement. And I want to ask that person, what do you mean Websites are currently attacking my home router. What type of security enhancement is that? Here kind of began the hot potato game. No browser really wanted to deal with solving this because there wasn't a standard that they all had to comply to. They were scared that they would implement and put money and time into implementing a security feature, and then later a standard would come up and they would have to ruin all the code that they wrote at that time. By saying this is not a Firefox-specific problem, they tried to throw the hot potato at someone else. To this day, Mozilla did not figure it out. They closed the bug, opened the bug, made it a bit more critical, but it's still open. That's what matters. This brings me to the main problem that browsers have today: lack of standardization. They don't have any standards. A few years passed by, we're still on the same bug report, and someone commented they have seen Chrome started working on CORS to restrict cross-origin access. CORS was a step. Allowing domains to decide who can ask for their data or resources was a big change at the time for browsers. But it focused on not sending the response back, meaning only after the request was sent and digested. And it still didn't prevent access to local and internal networks. That's where PNA, a private network access, will come in later, but I'll show you how we broke that too. Later, Mozilla marked this as depending on PNA, meaning they wouldn't put more effort into implementing and closing this bug, waiting for someone else to implement this. One eternity later, this headline appears. Why is this website port scanning me? Who remembers this headline from Hacker News? Okay, this headline appeared on Hacker News in 2020, mid-COVID. I'm sure you all were busy doing something else, that's why. And apparently eBay, not some script kid, but a big company, was caught scanning clients' local ports. We don't really know why they did this at the time. It could have been for security reasons, for fingerprinting to prevent fraud, or they were using an extension and the extension was doing this and they weren't really aware that it was doing it. Until today, we don't really know the reason, but at the time, it made quite a huge noise. But how did they actually do it? They were using Localhost, or 127.0.0.1, for the scanning. This is an address that saves for the device itself. Quite intrusive, right? This shouldn't happen. Browsers shouldn't be able to access your local device over the network. It's that simple, at least in our opinion. So we don't really know why it happened and whose fault it is, but we do know this shouldn't be possible to do. And it really did spark a conversation, and it led Chrome to start working seriously on private network access. Well, if you didn't really understand what I said till now, this explains it best. Just like when you visit a website with a public domain, imagine you walk into a store and the store scans your entire contact list on your phone to understand who you live with and who you communicate on a daily basis. That shouldn't happen either, right? Well, both the bug report on Mozilla's bug tracking system and the eBay case are connected. And as I said, they inspired the PNA development. So let's move on to talking about PNA, private network access. From now on, I'm just going to be saying PNA to shorten it all, and I hope everyone will understand. So when I talk about networks, I want to talk about three distinctive networks. Think of it like this. You are the local network, and you live in your house, the private network. Your house has a bathroom, a living room, a bedroom, and any other rooms that you want. All are different private networks. Your house is connected to a street, the public network. The street connects your house to other houses, to a park, to a conference room, to whatever you want, to different places outside. So these are the three distinctive networks that we want to talk about. The public network, meaning internet today as we know it. Everything with a public domain or a .com, for an example. The private network, the home or office network. It's kind of the entity that represents us in front of the world. And finally, the local device, meaning our phone or computer. It's used for services and programs that run on our device or for testing infrastructure, meaning developers use the local network a lot. So, private network access is a rule that says websites from the outside world can't automatically use stuff from my internal network. Before a website can use my printer or smart TV in my home, it has to ask permission for this. This keeps my stuff safe from strangers outside. Think of it like this. P&A is like a front desk in a building. Public visitors from the outside, websites, need permission before entering more private rooms, my local device. So here things got a bit funky. What is actually defined as local? Here my team started thinking about how we can hack this young and immature security concept. So here are 4 different ways to run a server on your machine. The first 2 ways are ways to bind your server on all network interfaces on your computer. And the last 2 ways are running specifically on your local network. You'd think that running something on your computer would mean that it would be safe. But from now on, whenever I'm going to refer to localhost, I'm going to refer to the 2 lower addresses, 127.0.0.1 and localhost. But you may ask, what is 0.0.0.0? And from now on, so I won't repeat myself too much, I'll just say 0.0. So according to Wikipedia, the IPv4 address 0.0 can have multiple uses. You might already be thinking, all the IPs on this host, all the network interfaces on this host, or just simply localhost. Well, one thing I can promise you is when something has multiple uses, it can be abused. And let's align on it. Well, 0.0 is this host on this machine in Unix machines. It's an abstract way to look at all of the network interfaces available on a host. It should never be used as a destination, but only as a source, or when a host is learning its IP. And you know how hackers love do not use. So let's move on to talking about 0.0.0.0 day. So when they started working on P&A, they compiled a list of all the addresses that they don't want hackers or people from the outside to use. So more private domains are blocked when using P&A. This is the list they created. They added localhost and 127.0.0.1, host file records, and IP addresses that are reserved for private networks. So with P&A, if you try to access one of these addresses, it'll get blocked. But remember the hot potato? Well, they forgot to add 0.0.0.0. So it's left out of P&A. Because 0.0.0.0 was once used in different initialization processes, adding it to P&A made many websites crash. So with using this address, 0.0, we can access local hosts and local networks. And I just want to say that for a side note, this is only possible in Linux and Mac OS, meaning Unix machines, because in Windows, this isn't really an abstract way to access all of the network interfaces. So when we use 0.0, we can actually access localhost and 127 and 0.0.1. And this is a unique attack vector. It doesn't come up with security scanners. It's not blocked in classic firewalls. And it easily exposes many of your secrets because it lets the attacker connect to your localhost. So when PNA in Unix ignores 00, it's like a security guard forgets to check a door tagged "Do not use 00." Unwanted visitors still find their way inside the building through this door. But what can we actually access with this address? Well, everything that is port forwarded, everything HTTP that is port forwarded, meaning a lot of developer processes and tools, operating system services that run on localhost or that are bound to 00 interfaces, and internal network access. VPN sometimes is configured after binding to 00, and it could lead to DNS rebinding. But let's talk about a real-world example of how we use this vulnerability in my team. So Shadow Ray, not from the browser, was a research that we did in our team before 00. We wanted to show that Shadow Ray is also possible, among many other things, used through 00. So here's what we actually did. Who here has ever heard of Ray? Okay, one person. Thank you for the support. Ray is an open source framework that makes it easy to scale AI applications from your computer to the cluster. It's used by many vendors, as you can see on the slide, including OpenAI. And to quote OpenAI, they also use it to train ChatGPT, meaning I think you all need to get up with your AI learning. So 2023 was a big year for Ray. In late 2023, 5 unique vulnerabilities were disclosed to the maintainers of Ray. Following the disclosure, 4 of them were promised to be fixed in the next version of Ray. But the 5th one remained disputed. And we thought that the 5th one was the most important. It's part of the jobs API, meaning it's on by default, and it enables running any command that you want on the cluster. The vulnerability claims that Ray lacks authorization, therefore creating remote code execution by design. The fact that it's disputed means that it doesn't come up with security scans, and not the user or the developer is even aware of this behavior. The maintainers claimed at the time that it was lack of authorization, and it remains running on a local network. Therefore, it's more of a feature than a bug. And as they said here, it is not intended for use outside of a strictly controlled network environment. So you see where I'm going with this? Now, think about it for a second. There's a vulnerability. The report is public. The maintainers say it out loud. This is not a vulnerability, and it's not a bug. It's more of a feature, and it won't be fixed in future versions of Ray, because it's essentially the purpose of Ray. It is the developer's responsibility from now on, and we all know how that ends. And I want to just talk about how attackers love and look for disputed CVEs. It's everything they ever could dream of. Someone already did all the hard work for them. The report is outside, and the maintainers promise to never fix it in future versions. They often let them have them backdoors inside the company. And as I said before, security scanners don't even alert for this behavior. Here you can see the default deployment configuration of a Ray dashboard out in the wild. As you can see, our favorite address, 0000. With a lack of a firewall or a security policy, it might expose Ray to the public internet. So let's talk about the impact and what we could actually achieve from Shadow Ray. I just want to note that all the following data that I'm going to show you was achieved from internet-facing Ray clusters that we found out in the wild, meaning it was part of the first and initial research that we did. We didn't hack into anyone's local network. We're going to show that it's possible later. But the reason I'm showing you this is because I want to stress how attackers are looking for AI workloads and how they could easily access all of your production environment just from that. So we could access AI production workloads, meaning we could have access to models and data poisoning and tampering with data with model training. We accessed production DB credentials and passwords, and also private SSH keys. We also could access OpenAI tokens, Hugging Face tokens, Stripe and Slack tokens, and cloud environment access, meaning jackpot, we won. Some of the impacted machines were compromised for at least 7 months, and this was about 1.5 years ago. Many of the machines included command history, making it much easier for attackers to understand if this is a useful machine that they want to actually investigate, but also, happily, made it easy for us to understand if attackers were there before. This is a Ray dashboard that in the wild that we found and was exposed to the internet. And I don't know if you can see, but not surprising, some attackers were there before us, and they opened reverse shells using wget and nc, both present inside the Ray environment. So we proved that AI infrastructure is targeted, and it could easily lead to all of your production environment. So I wish I could talk about this a bit more, but you're more than welcome to also search about it a bit more on our blog, Shadow Ray. And I just want to talk about how the maintainers of Ray said that this is possible only with internet-facing Ray clusters or with access to the actual Ray machine itself. Meaning, by design, the developers that deployed these Ray clusters made a mistake, and this is on them. But we want to test it out and prove them wrong. As security researchers, we know that at the end of the day, the developers have the responsibility for the code. But real life and reality is much more complicated than that. So using 000, we could attack a local network running Ray without direct internet access. And this is how we did it. So this is the attack vector. The victim uses Ray on localhost or a private network with port forwarding, just like it's designed to. The victim later visits the attacker website or clicks a malicious link. JavaScript then invokes an HTTP post request to the Ray API by using 00 as target IP. As you can see here, this is a simple and honest email sent to one of our developers. Please click here if you can't see the email. Ray was recently updated. But unfortunately, the link leads to a malicious HTML. This is another visualization for the attack flow. The developer deploys Ray on a local network, thinking it's safe from the outside world. But it accidentally clicks or visits the attacker's website. The attacker then sends the malicious request with the target IP 0000. So you're going to see a one-click demo that results in a reverse shell on our victim's Ray cluster. We can see the developer on the local terminal. In the middle, we can see the developer's browser, and on the left, I think, it's the attacker's shell. And a connection was formed, established. And we can see a command was executed on the Ray cluster, resulting in a reverse shell. Thank you. Yeah, pretty cool. Well, I know you're all scared and probably asking yourself, oh my God, well, I just want to calm you all down. Yes, we did this in all 3 public browsers, Safari, Firefox, and Chrome. I know. So this is the exploitation in Safari, Firefox, and Chrome by order. We can see it, but as it's the same thing as I showed you before. And 0000 Day made quite a buzz at the time. It appeared at Forbes, Hacker News, and different websites. So let's move on to talking about the current state of browsers today. The lack of a finalized standard led to different implementation in different browsers. This means that every browser implements the HTTP request to internal networks in a different way. Let's start with Safari. Following a report, Apple made breaking changes to WebKit that blocks access to 0000. As you can see, the PR was merged. Apple-based browsers use an open source software called WebKit. And as part of the change, they checked when a request was handled if the target IP is all zeros. If so, it blocks the request. So I'm sorry to say that my team added a line of code to every HTTP request in the world. And this is a check that we did like last week. We try to access 0000 over Safari, and you can see the error that we got back, not allowed to use restricted network host. So Chromium was an interesting case. So before they released the fix, Chrome wanted to understand how many websites were actually using this address. So they released a counter in one of their versions, and they waited to see the results. Sounds legit so far, right? Yes, this is their suggestion. And so based on the counters that they released, the use of 00 rose from 0.001 to 0.015%, more than 10 times over the course of, I think it's 2 years since they were added. We're talking about 100K websites that communicate over 00. Well, I was interested in what's the status of the counter, so I went back and I checked it last week. And surprisingly, there was a spike around August 2024. Can someone guess what happened during this time? Well, my team was invited to talk about this at DEF CON, August 2024. And yeah, believe it or not, attackers actually watched DEF CON talks. Who could have thought of that? So following the counter, Chromium said they're issuing a fix as part of P&A, but after breaking some old websites, they had to revert the change. They're currently waiting on the fetch specification. Fetch is the way to do HTTP requests in JavaScript to handle it properly. Remember the hot potato game? So yeah, they're waiting on the fetch specification. But as I said before, that Apple-based browsers use WebKit. So if you're using an iPhone or a MacBook, it doesn't matter if you're using Safari or Chromium, you're safe because they all have to use WebKit. And finishing with the Firefox, the browser that started it all. As of now, there's no immediate fix in Firefox. Although a fix is in progress, Firefox at some point said that they're waiting for P&A, then they said they're waiting for fetch. And as you can see, the fetch PR is still open. It's still open right now. I checked it last week, and I saw a list of a lot of angry users commenting. So it's funny to just read the comments. So at an undetermined point in the future, 0000 will hopefully be blocked from access in Firefox and will not depend on P&A implementation. So let's move on to talking about conclusion. What you must be asking yourself, well, Britt, what's the best practice? What should I do from now? First and biggest best practice is never trust localhost just because it's local. A good example for that is Jupyter Notebook developers. They implemented a default token, and they did a great job by doing so. The second best practice is implement P&A headers. Just like cores kind of became a standard in web development, P&A headers, as I think, would be part of our future, and that would help protect, and in Shadow Ray's case, would have made our exploitation not accessed. Oh, okay. And also use HTTPS whenever possible. So what to expect from the future? Well, as I said before, hopefully P&A headers will be added to open source projects, and I'm relying on you guys to start implementing my best practice in open source projects. Just like course headers are quite the standard. Hopefully 0000 will be blocked in all browsers in the future, but we don't really know when that's going to happen. And developers will become super secure after this talk. I'm just kidding. We all know that's not going to happen, especially with AI writing more and more code today. But that's just going to promise, that's just giving me a job security, and it's going to promise more and more interesting talks in the future. So I think that would be part of like a happy future in the end. And I just want to say that there are many other cases like Shadow Ray, and research is done. And just to finish with a tease, MCP uses HTTP and no auth, and we're currently in the MCP buzzworld. So if you want to check that out and maybe write something, you're more than welcome. Go look at it. And you're also welcome to read our blog post about this. Yeah, that's it. If anyone has questions, thank you. Are there any questions? Yes.
Have you considered submitting CodeQL or SemGrep rules, like to the community side, to like remind developers as they're coding, implement the P&A header?
Honestly, no. I don't have a good reason why not. But I didn't look into it too much. But I know that like we did this research as part of improving our product. So we took the conclusions and we implemented them in our products. Yes?
I was going to say, I know you talked about AI, and this wasn't super really about AI, but I was just kind of curious. Are there things that you've like seen companies do with AI that kind of make you shake your head, or like kind of, not necessarily dumb, but kind of mistakes companies have made in attempt like with AI implemented in software? Have you seen that or not really?
I think the best example for that is just like Shadow Ray, when companies think that AI isn't very production code or isn't very connected to their production and responsibility for developers, especially now that the divisions between developers and data scientists are still a bit far from each other. So that's like most of our researches are focused on that. I think AI, you could talk about vibe coding forever, but yeah, that's mostly Shadow Ray and stuff like that exposed. Yes?
Can you go into a bit more detail on how P&A pre-flight headers work?
Yeah, so P&A headers are mostly part of the browser checking if it could send, if the domain allows access to local networks. So your code, your local code has to send like a header like, hey, I allow other domains and public networks to access my code. So it's basically, if the Ray maintainers would have developed it, they would have like either said no or yes. And instead they were just like, no, it's supposed to be part of a local network, it's okay. Yes?
What about blocking it in firewalls?
0, 0. Yeah. Well, as I said before, it's because it's In what type of in what step?
Windows firewall. Just, putting an inbound and outbound block on 0, 0.
Because still there are you could implement it as your private case, but it's not a suggestion because it's still an interface in Unix. In Windows, it's not a problem. This wouldn't be able to be done in Windows, but because it's a difficult concept and complex concept in Unix, it's still a bit problematic. So you might do that in a private case if you check that it's okay, but in an abstract way, no. Okay, so if there are no more questions, thank you so much. Follow me on Twitter, add me on LinkedIn, and thank you for coming to my talk.